what we did is we're going to, we talked about slope, the rise over run, the change in y over the change in x, whatever. Using the formula, not using the formula, using a line, not using a line, and the y-intercept. This is just going to be some stuff that gets us ahead a little bit. So I'm going to show you three things. I'm going to show you using the rise over run to create the line. I'm going to show you how to find the slope, and then how to use the y-intercept. So you can always depend on x being 0 and y, whatever y is when x is 0, is your y-intercept. Okay, we'll just plot that one, and that's also right here. That tells you the y-coordinate to plot. This is known as your slope, which is how far you go up and down, and how far you go left and right, depending on if the numbers are positive or negative. For example, 3 over 2, up 3 over 2. They're both positive, so I'm going up, positive 3, right, positive 2. And do the reverse of that, it would be a negative 3 and a negative 2, which would be down 3, left 2, down 3, left 2. And I have all of these points plotted without actually plotting any of those points. So let's talk about how to find slope. You can always just find the change. 3 to 6 is plus 3, and then 0 to 2 is plus 2. You got 3 over 2. You can also label them your y2, y1, x2, x1, and use the formula. y2 is 3 minus y1, 6. x2 is 0 minus x1 is 2. Whenever you subtract this, you'll get negative 3 over negative 2, which is exactly what we use to make the line go down, and this is what we use to make the line go up. That routine will never change. Let me demonstrate. You can see here that x is 0, or y is 2. I'm going to plot that. I would advise having graph paper ready at all times and have a big plus sign on the paper. This is also where you can find the y-intercept. That's where you start. You can use the slope up 3, right 2, up 3, right 2, up 3, right 2. You can always do the opposite, negative 3, negative 2, down 3, left 2, down 3, left 2, down 3, left 2. I just plotted all of these without plotting them. You also have the option of just plotting these points, of course. But the thing we're looking for is how do you find slope? That's a change of minus 3. That's a change of minus 2. So that's negative 3 over negative 2. You'd also use the formula, y2 minus y1, x2 minus x1. That would be 5 minus 2 and 2 minus 0 will give you 3 over 2. You can see that this is the equal and opposite slope that created this line. And this slope is also found right here. It's the thing that's always next to your variable. This one looks weird because it is. You can see that it's increasing by 2. And that's a horrible 2. Increasing by 2, and then this is increasing or decreasing by 0. So what does that look like? Let's plot a point. 4, 2. Okay, so over 4, 2, and then it goes up by 2 from there because the coordinate for x stays 4. I want you to look at the rise and the run. It's rising by 2, running 0. Rising by 2, rising by 2, rising by 2. Notice that we haven't moved to the left or right any, except for where the coordinate said to go. The rise and the run tell us where to go from one of these points. Notice that there's nothing being added or subtracted, and the reason is we have nothing crossing through the y-axis. If we wanted to reverse this, do a negative 2, it would look like this. Down 2, down 2, down 2, down 2. This would also be called undefined. Because no matter how much of x you have, the y value is constantly changing for infinite amount of numbers. You would also define this as a vertical line. You can't say that there is a slope. It's undefined because there are so many. Know that it's called undefined and know that it's vertical. Those are two important words. I'm going to start with the equation. Plot negative 5. Okay, 1, 2, 3, 4, 5. And you can see here, there is no y-intercept. But what we can do is we can plot one of these. Like, for example, I'm going to plot 2, 1. Okay? Now I'm going to use the slope. Oh, dang, what? There's only one number. What am I supposed to do? Underneath every whole number, there's always a 1, because 3 divided by 1 is still 3. So you can turn anything into an improper fraction over 1, and it will still maintain its value. I'm going to pick some random ones. 1 to 10 is plus 9. 2 to 5 is plus 3. That's 9 over 3. That's the same thing as 3 over 1, which is the same thing as 3. Let's use the formula. 2, 1, 2, 1. You can pick any two numbers. Just make sure they're corresponding to each other as their respective x and y value. Negative 2 minus 1, y2 minus y1, and then 1 minus 2. That would equal negative 2 plus negative 1 is negative 3, negative 1. Oh my gosh, the equal and opposite of what we originally found. So let's use this slope, and this will always find your slope. So if this is looking confusing, then just find your slope from the table, find the slope from the coordinates. So watch this. All right, so I'm going to choose from right here, since we didn't have the y-intercept, and I'm going to end up on the y-intercept. Down 3, left 1, down 3, left, bam, down 3, left 1. So then I'm going to use the actual slope that was given, not its opposite. Up 3 over 1, up 3 over 1, up 3 over 1. You can see how this is going to form a line every single time. If for some reason you have a line right here and then it starts going like this, you know you made a mistake. That's not what lines do, okay?